Hello, 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 hello. Good morning, 8:30 a.m., Tuesday. Healthy crowd out there. Great to see everybody. This session you're here to sit through is called Digital Transformation Through APIs. There's going to be kind of a back and forth between sort of the idea of doing API strategy and how you can actually go through and use enabling features of API Gateway to deliver on that strategy. We'll start talking a little bit about what digital transformations are, and then I'll bring up Benjamin, who's from here, who Here Technologies, they work with mapping. They bring mapping services to developers. They have some interesting new services that they've honestly gone through their own digital transformation to bring to market. I've worked with Here Technologies for over 3 years. My name's Tom Fuller. I'm a solution architect out of Atlanta. This is my 4th reInvent. And so this is the first reInvent that I've done a Tuesday AM session, and I'm really happy to see so many people. I also thought it was interesting that last night, and show of hands, how many people went and saw Metallica last night? A few? Is there any? There's one over here. It might have been a little difficult to bring through to the 8:30 a.m. session if you went and saw Metallica last night, but I found that pretty interesting that those schedules overlapped. So what are you going to see in this session? We're going to go in and we're going to start with a little bit about modern app development. Then we're going to talk digital transformations. And then we'll really get into the meat of it. And I've got 6 distinct strategies that we'll talk about for using API Gateway and working through an API strategy that'll help make you successful. Kind of another straw survey. I like to kind of get a sense of it. How many in the room are developers, writing code, bringing APIs to market? Awesome, cool. How many are here to kind of think about the strategy and are more on the architecture side? That's almost 50-50 unless there was people double hand raising, which is fine. So modern app development, and this is a common thread that you're going to see through a lot of the serverless technology sessions here at reInvent this week. So this is probably the first time you're going to see it. It may not be your last. But really, what are modern applications? These are characteristics of applications that we would call, quote unquote, modern. And it's really about the mechanisms that you use to bring these types of applications to your customers that's interesting, right? So enabling security throughout the entire life cycle is an example. Building things in a modular way, right? Who's heard of microservices? I'm sure you're going to hear the word microservices quite a few times. I'm not on a quota for this, but I'm going to say microservices a few more times. Microservices and 12-factor and sort of the way in which you kind of determine the modularity of your applications is a big thing as well. And resiliency, and that's about protecting the reputation of what you're bringing to your customers. And there's really nothing more resilient than a serverless technology that's managed on your behalf, that's deployed and scaled and operated on your behalf. And then really automation. So how do you do CI/CD? How do you kind of really crank up the velocity of how you're changing your applications? These are all those things that we would say are modern. And at no point, other than the fact that I talked about resiliency with serverless, did I give you the sense that there's only one specific way you can build these types of applications. I'm also not really focusing on the API element of it at this point. But suffice it to say, I mean, APIs are everywhere, right? There's this terminology that goes around right now, we'll talk about it a little bit later, of the API economy, right? So every application, every client and consumer that can go and make a call from a vehicle or from your refrigerator is calling APIs on the back end. Digital transformations, and I was trying to think of a way to just sort of frame up the idea of digital transformations. And digital transformations aren't new, right? We can go way back in time. In fact, I'll give you an example here in a little bit that is near and dear to my heart. But you guys have all been sitting here, guys and gals, have been looking at this for a little while. And if you're familiar with it, this is the ink blot test, the Rorschach test. And there's different ways to interpret it, right? This is a couple of the more popular things. Is it a bat? Is it a moth? But if you sort of look at it sideways, you think about it, maybe it's a pig standing on a hill with long ears. And the reason I use that as a illustration is because it's a little bit what digital transformations are like to customers and developers and architects. It's sort of in the eye of the beholder what that digital transformation actually is. And so maybe it's you going through and taking a monolithic application and splitting it all apart into smaller modular chunks, services that can evolve and version differently. Maybe it's you're trying to modernize so that you can retire. a API that is something you don't want to operate anymore. Maybe you're looking for new business opportunities. Maybe what you had traditionally done was a FTP drop point and you need to go and do something more modern and capable with an API front end. And then maybe you're just trying to increase your reach. Maybe you're looking to get into a new region. Maybe you're looking to get into some emerging business that you had never considered in the past. These are all quote unquote transformations, right? So you all decided to come to this session, and the title is somewhat generic and intentionally so, right? Digital transformations mean a lot of different things to a lot of different people. So Amazon itself went through a digital transformation. This story's been told time and time again, so I'm not going to go into the details of it. But 20 years ago, there was this monolithic e-commerce application that needed to sort of be refactored and brought out as services, right? So the classic story goes, it was a mandate that services would always be how those components would interface with each other. And that was the start of something called Amazon Web Services, right? That's the genesis story of Amazon Web Services. Now you see here this little peculiar logo. In fact, when I started almost 5 years ago at AWS. You see this logo on a lot of the things you get going through as far as our training is concerned. And it's that we do things a little bit differently. One is, we almost never retire API endpoints. If anybody's interested after this session, we can go and we can download an old version of the SDK, and we can deploy an M1 small into EC2 Classic in US East 1, not 2, right? So there are things we do start to go away from, right? EC2 Classic isn't in new regions when they're brought on, but we do actually still have APIs up and running because someone took a dependency on those, and so that's a really important thing to consider, and it comes with a really important step, which is that you have to work backwards from what's being built. And this is another thing kind of in the classic culture of AWS and Amazon, working backwards from what customers need. The reason I mention it is because if you're gonna not retire an API, you have to know that it's useful for someone. You can't, otherwise you're at risk of sprawling things all over the place. So those are some really interesting examples kind of digital transformations, plus kind of how APIs start to come into the picture. I like this quote. I like this quote for a couple of reasons. Hope is not a strategy. So obviously we're transitioning now into kind of the strategy itself. And sort of what are those API strategy items? Now this was said by James Cameron, and the story is interesting. So as Avatar was being done, he actually had T-shirts made that said this for the cast. And the reason why was because they needed to be intentional. They needed to have a strategy. They needed to be very, ownership was key to everything. And so there was big risks taken on Avatar. Now you can't argue with the results. The top 2 grossing movies of all time, Avatar and Titanic, still to this day, are based on that. So strategy is key. Luck is not a factor. Fear is not an option. Okay, now we're going to get into the kind of guts of this. First and foremost, I think we all can agree APIs are everywhere, right? We have companies that are defined by their APIs. If those APIs aren't being enhanced or versioned or changed, developers go away. Like this isn't a very captive audience anymore. It's a very fickle audience, and you have to always be thinking about how to continue to evolve. Microservices certainly puts a lot more of those APIs into the market. And REST, what a huge change that was. I mean, I can remember the days of lots of XML and SOAP and standards, and that's all sort of way in the past at this point. And so REST has created this universally capable way of invoking these APIs. And so now everything that has compute that runs anywhere and everywhere, and of course the pervasiveness of connectivity is huge as well. And so IBM did a study, this was last year, and so this year, 2018, they said the API economy is estimated to be $2.2 trillion. So that's a big pie to go take a piece from. It's a Thanksgiving reference. So Amazon API Gateway, and the service has been out for a few years. This is about managing those APIs, publishing them, maintaining them, monitoring them, securing them at any scale, right? So capabilities have been out there for doing, reverse proxies and rate limiting, open source software like Nginx, but this is a managed service. And it integrates directly with AWS service features like IAM, Identity and Access Management, like Lambda, right? I'm not going to go into details on full-on serverless, between API Gateway and Lambda, but those are the kinds of integrations that have come on over time, step functions. And then you see kind of how we've given you ways to make your life easier, like SDK generation, right, for iOS and for Android. So the ability to get a SIG-v4 signature generated so that you can put authorization controls on top of your APIs, all based on native capabilities inside of API Gateway. So we're going to dig into a few more of these based on 6 specific strategies. And these are the things, these aren't necessarily the strategies to rule all strategies, but they are very important, and they do map to capabilities that we continue to bring to market and enhance and version around API Gateway. So ease of use. So what does it mean to be developer friendly? I mean, that could mean a lot of different things to different folks in the room. If you're a developer, it means, for myself, and I've slung if statements and for loops for 20 years. I want to be able to go look at documentation. I want it to be clear. I want it to be concise. I want it to be up to date. That'd be nice, right? I want it to be able to be something that I can go look at and understand without having to do too much hacking, failed code, retry, right? That kind of iteration cycle can cause a developer to flee. And so, being developer friendly is really important. Do we need an SDK or do we not need an SDK? We talked about REST just a couple of slides ago. REST is an open protocol. You can go against the REST heads of just about any API, but is that developer friendly? Right? So if that API isn't sort of described and made available to the SDK, is it too hard to build a client? Is it too hard to build a consuming application? And information about your future plans can go a long way to getting folks really embracing your ecosystem, right? So, you can see these things in version releases. We're in the era where if your API is out available to look at, there's going to be what's the velocity on the contributing, what are the kind of pull requests, how long are they sitting idle? Like, those are the kinds of things people are going to look at. And so you got to have an easy way to describe your API. And that mechanism needs to be based on something that's a standard. Why? Because the tooling that's out there bases its capabilities on these standards. So we have the Open API specification, which sort of evolved out of Swagger. So if you're familiar with Swagger, this is sort of the next step of that. And now being able to import and export, this is an example of a feature of API Gateway that allows you to work with your API, managed, hosted, deployed, scaled securely, but then also export it and then look at it in whatever tooling that you like. And actually, Benjamin will talk a little bit about a very practical example where they use that. But basically, at this point, you're defining your model. You're defining all the different pieces and parts of your API, and it's a standard way to go about that. If you hadn't noticed, we did release in October a new developer portal. Now, there had been kind of a GitHub project sitting out there for quite some time, but this is really important for developer friendliness and ease of use. This developer portal lets you do self-service API key generation. This developer portal lets you list all of your APIs. This developer portal lets you click through into your documentation, right? So this is an add-on component to API Gateway, and there's been 6 releases since the end of October. The velocity on this thing is really impressive. And I like this little feature here in the corner, try me out. You don't necessarily have to go write a bunch of code. Deploy this, catalog your APIs, and give folks a way to test it out from the developer portal directly. And so there are a couple features out here. I had a nice conversation with the service leads on this. They want everybody to know that go vote, go +1 the features that are being built inside of the GitHub repo. Right? This is one of those things, and I'm super proud of how this has evolved inside of AWS. There's a lot of these kind of stories today where it's being done in the clear. Like, you can see what are the priorities that the teams are working on. And in this case, it's a really great one for you to have an API able to be consumed and used by developers. XRay Tracing. This is pretty cool, too, from an ease of use perspective. You really kind of want to get a sense of how fast is kind of the average response time of my API. And that's not a trivial thing for you to instrument out of the box. Now, what we've built is a way for you to, either in an active fashion or a passive fashion, enable this sampling. So you can get a histogram like you see on the left-hand side of showing you what are the performance points across all the different touch points as the API is being invoked and called. So XRay Tracing, you may have heard a little bit about that, but it may not have been obvious to you how API Gateway sits at the front of that and enables it and makes it something that you can consume and use and look at. All right, that was ease of use. A couple cool features of API Gateway in there that are available for you to just bolt on. If you hadn't heard about them, awesome. I hope you go take a look at them. Strategy number 2, customer segmentation. Now, interestingly enough, right, this isn't something we do at AWS, right? There's not a premium version of the APIs that you get access to if you spend a little bit more. Now, what we do, though, is we do set quotas. We do set limits. Who's ever had a limit that they hit on AWS? There has to be some hands up for that, right? It happens, and we do things in a conservative way. Now, this is where I would say customer segmentation versus protecting your reputation for your API tend to have a pretty highly overlapping Venn diagram. So you need to kind of think about both components here. But for you as an API developer, somebody deploying to a customer base, this is something you could actually build a monetization strategy around, right? So I could have premium users. I could have developer accounts that are free, right? I could do a lot of different things. But how do you keep them engaged? How do you keep them active and happy? And that comes into using things like usage plans. So usage plans aren't brand new, but they continue to evolve. And this is an API Gateway feature that lets you take API keys, align them with a stage, and we'll talk a little bit about that in a minute. But the stages would let you basically set up these throttles and then quotas, right? So maybe if you pay an extra amount, you can have 2 million requests a month, versus if you just had a developer account, you could just do 500 and then eventually you hit a limit, right? This is one of those kind of features, one of these capabilities that you want to implement. Now, this would not be trivial for you to implement on your own, right? This is one of those things that is available inside of API Gateway. And we'll talk a little bit more about kind of the technology under the covers here with throttles and limits. But it's also important to remember that point I made about AWS, which is protect your customers from each other, right? So malform requests, how do you sort of do circuit breaker technologies based on some of this? And so that's an important thing to consider. So now, bursts, and the token bucket algorithm is not a new one, but it is one that you've seen kind of start to show up across a lot of the different capabilities inside of AWS. You may have seen this with like the T family EC2 instances. You may have seen this with EBS and sort of some of the burst storage credits that we work with there. Now, there's a fundamental difference here between token bucket and leaky bucket. They both have buckets, so there's some similarities as well, right? But the metaphor is a little different in that a leaky bucket, and actually Nginx's rate limiting is like this, where as the token credits are being input, basically the rate that you're allowed to consume, it basically does a first in, first out with leaky bucket. That is not what we've implemented here, and the risk of this is jitter, right? But I mean, this is a tried and true way of doing telecom switches, networking and rate limiting for years and years and years and years. And we've seen a lot of success with how this is done inside of other services and capabilities inside of AWS. And so you kind of stand at the center of what are the right parameters, and it's all based on what your tolerance level is for jitter between your customers. So if you want to set a rate of 500 and a burst of 5,000, right, that's a potential huge swing. Now, maybe your API has those kinds of requirements. Maybe there is sort of huge variability in the types of load that your customers are going to put on there. But again, remember, this ties back to your usage plans. So maybe some of your customers are allowed to go well beyond their rate because they have some sort of a premium subscription with you, and maybe others do start to queue up, and they do start to have something that on the client side you could try to gracefully handle. But it's important to know that this is a feature, a capability that you just get out of the box with API Gateway by implementing it on top of a usage plan. All right, strategy 3, securing your API, right? And so securing your API, there's nobody in this room that would think that if your API is ever compromised or if somebody perceives there to be a security risk that it's going to be used by developers. It's not going to be used by anybody. It's going to end up some kind of IP blacklist. It's never going to be consumed. So you really have to think about security. It's important to your reputation. It's important to your API ever being successful with your customers. Policy and mapping policies to those roles is how you go about that. And the features and capabilities inside of API Gateway really comes down to IAM, right? And IAM in a more interesting way because it's integrated fully, and then you can start to layer on top of that the roles that you've built inside of AWS and put that in front of your own API. Now this really didn't exist in the past. You didn't have a way to put a layer of API management in front of whatever you were building and then use AWS's identity and access management capabilities to control it. And then we give you all the SIG-v4 generated tokens and everything that you need to be able to do that kind of authentication and authorization. And so obviously with that, you start getting all your keys rotated. You get all the goodness of identity and access management right out of the box. So this is an important one to keep in mind and just keep thinking about all those kind of core security concepts, least privilege, and thinking about that as you define the roles. All right, number 4, innovate with analytics. And the data never lies, right? You could make gut kind of decisions around which parts of your API are useful, which parts of your API aren't useful, but really the data never lies. And so you really should be looking at all the various logs that you can collect. You should be trying to understand real usage of your APIs. When are they being used? How about like in an example of like an alpha, beta, life cycle, you try to take a look at what the usage patterns were of your beta service before you determine if it's had enough activity to it to be switched into a live feature. Right? There's a lot of different things that you can do here, but the key is to collect those logs, and here are those logs. Quick little snapshot of an access log, and we give that to you out of the box with API Gateway. So you've got in JSON format, XML format, CSV format, you can start to collect, where did it come from? What was the time of day? Where, from an IP perspective, or the different types of calls, right? So you can see the resource paths, so you can see exactly what's being called and invoked, and you can collect that. I mean, there's a lot of cool things you could do there. You could collect it, store it in S3, run Athena queries on top of it, do all kinds of interesting analysis. Execution logs, so you can feed in to the log groups and log streams. What are all the things that are going on for your API? So what are the errors? What are the things that you need to do some additional triage and research for? And then CloudWatch metrics, so how many 400 errors, 500 errors, what are the things that are going on in your API? Cache hits. I don't get into detail on caching, but it is a feature of Amazon API Gateway. So a good cache is one where the usage of it is high enough that you're not constantly flushing it. So analyze that, right? Otherwise, you're just spending money for no good reason. And then CloudTrail for auditing. So now if you needed to know, say it's a security feature where somebody's changing a password, you need to know when that was done, who it was done by. That's a CloudTrail feature that's also built into API Gateway. We like the idea of easing into retirement for some of your APIs with serverless. And this is kind of the slide where I talk a little bit about API Gateway in front of Lambda by default. And what you end up getting here is a reduction in the cost of operating, say, even the smallest API you can imagine that I'm running on a couple of EC2 instances. If you do that, you've got to deploy that across availability zones. You want to do that for high availability purposes. But if you did that with serverless, now you're out of the business of actually having to patch and operate all of that infrastructure. Again, even the smallest services and APIs are much more cost-effective if you consider the idea that Lambda could just host them for you. So this is another interesting strategy that you could start to take a look at. And how would you know to do this? Well, go back to the logs, right? Like, what's the frequency that these things are being hit, and should I really still be kind of operating this whole infrastructure to support that? Protect your reputation. And I will say that I think it was really hard for me to decide if I should put the stuff around usage plans here or if I should put it up where I did in customer segmentation. I think it honestly kind of belongs in both. But so the tiering is still a part of protecting your reputation. I want that to be clear. But the other thing is, you can't let one bad apple ruin the fruit basket. Right? So you have to make sure that you protect the back end as much as you provide capabilities and segmentation for your customers. You got to be explicit. You've got to know kind of if you're going to provide an SLA, how does that get reported on? Right? Those are key elements to your API as well. And so we give you a way to do lifecycle management, just at a high level, kind of the things you'd be thinking about with a lifecycle is, as you're going through and creating an API, you're thinking about the design of it, you're thinking about what kind of your new version strategy would be, you're likely thinking about access control right up front. As you deploy it, now we need scaling capabilities, we need scaling features. And then you can see the rest, monitor, and then at the end, when I make the decision to version or retire, it's all driven by those analytics. And so I think stages and stacks working in concert is the feature, the capability of API Gateway and CloudFormation, right? There's no stacks concept in API Gateway, to be clear here. But it's the way they work together that's quite interesting. And we talked at the beginning about how everything needs to be automatable. It needs to be as code. And so CloudFormation gives you a way to layer down all that infrastructure, but then inside of API Gateway are these things called stages. And if we're talking about how that works with Lambda, that actually can go through a stage variables, and those can actually point at specific versions of different Lambda functions. And so stages gives you a mechanism, a really interesting mechanism in conjunction with stacks and CloudFormation. And again, Benjamin's going to talk about a much more practical example of this, but this is in your planning. This is how you go back and you can start to really get very iterative and very fast. Maybe you can get to a point in time where you're doing weekly releases because all of this stuff is automated and it's all built and you have some consistency and repeatability. Last but not least, is making money and monetization strategies. And so obviously there's a monetization strategy with Amazon Web Services, right? You all have seen a bill from Amazon Web Services if you operated on there in any reasonable size or reasonable amount of time. And you would want one as well. Now, how do you go about that? Like, there's different ways to drive through freemium models, ad-based models, those segmentations and those usage plans. And what we give you is we give you a way to use our marketplace. If you haven't seen this hasn't been around for that long. And these are just the 4 steps you would go through. You can see it's not particularly complex. What you have is you have an API packaged up with a usage plan. And the usage plan is a prerequisite, right? So that usage plan is the thing that you're defining on how that API can be called, the RAID and the burst and all of that. And then you register for the developer portal and you get a product code. That product code needs to map to an API key, and then people can go buy your usage plan on the marketplace. And so now a monetization strategy is available for you inside of the marketplace, and it works in concert with API Gateway. Okay, so to recap here, digital transformations are unique. They're challenging. They can be very rewarding. I think it'll be really interesting for you all to hear Benjamin talk about the transformation they went through. APIs aren't going to manage themselves, and hope is not a strategy. Remember that quote? So you want to define a strategy and understand what your strategy is, and then leverage the features to get that strategy implemented in the easiest way possible. API Gateway has a lot of those features for you. And I say this to customers all the time lately. You can't freeze your opinion in time. I think there is still a lot of really great capabilities and features that are going to continue to come to market around API Gateway. So if there's something there that's missing, if you have questions, I'd ask you to hold them to the end. I'm going to actually hand it off to Benjamin at this point, and he's going to tell you about the Xyze service.
Thanks, Thomas. Hi, my name is Benjamin Rögner, and I'm working for Here Technologies. And today I want to introduce you a bit to our new product called Xyze, and into our company and how we leverage API Gateway to get live. So here is the leading global provider of location, data, and services since over 30 years now. It has a growing role of digital mapping and location technology. So while improving quality of people's everyday life, with that, Here helps making roads safer, air cleaner, and enterprises and cities more efficient. So when I want to explain our company to a friend, I would tell him to go to his car and look to his navigation system. And most likely, in there, he would find a map being created by us, by Here. So we are kind of acting behind the scenes and creating maps and services. And once we created those maps, people mostly don't know that we created it. So this is kind of changing now. Let me talk about our new product, Xyze. So Xyze is currently in an open beta phase. It's called Xyze because it's working with coordinates of the 3-dimensional space we're living in. I'm a web developer, mainly a backend developer. And I'm not directly making maps, But now I can without losing a whole week on it. So it's very easy to get started and not have, and it's not really necessary to care about all the necessary things for geographical data manipulation and how to put it into the cloud. So the Xyze Hub offers spaces. This is a concept to upload and manage geographical data in the cloud. Once uploaded, data can be used with various clients. For example, an application in a web browser or mobile phone apps. Xyze consists of a set of visual tools and other components, of which one is the here CLI. And this CLI is just a command line interface which can be used by developers to easily upload data, which they then can later visualize and fetch it back. This is possible leveraging an infrastructure that scales, and also it's enabling developers to get started very quickly, even if they're a geo-newbie. So there's no need to care about how to get the data to the client, and also he doesn't need to care about the performance of that, because we are doing all the geographical stuff like tiling. So let me quickly introduce what is tiling. This is a short intro. So geographic vector data, called geofeatures, they are split into portions of data. And this is necessary in order to send them via web, even to smaller devices like mobile phones. This is a kind of preparation on the service side to actually make it possible sending the data, because otherwise you would have to send the whole data set, which can be the whole world actually, to the client. So just that short intro to tiling, there is much more behind it, but at the end, the point is that the developer coming to our API wouldn't have to care about that. So Xyze also offers a use of familiar tools, or tools our developers would be familiar with. And it's based on common standards like GeoJSON, which are out there in the industry. I, as a developer, I can use third-party or existing third-party libraries and just plug in any kind of renderer, data sources, and data formats. I can bring my own data, make changes to single geo features in the cloud, and share my map to others. Even as a non-developer, so being a geographer or a blogger or geo-hobbyist, I can make use of Xyze. This is our Xyze Studio, which is a web application. And there, the studio lets you create a project with multiple layers of data, so multiple geographic layers. And it lets you style this data and save your work and share it with others publicly in real time. So a sample would be some blogger uploading his cycling track to the cloud, then style this data, the different routes with different colors, for example, and then embed the map, or a map view at least, on his blog. So with that, I want to maybe introduce you to our technical or digital transition story. Also, we have one. So in the early days, we sold CDs and DVDs to our customers, which could install it in their car. Later on, we let them download map regions as files from an FTP server as bulk data. Then we had a web service, which is kind of open, but not in the way we could do it with APIs. So now we are changing to have a fine-grained access to single geo features on demand by using an API. So besides consuming data, the new thing is that we also have ingress data from our users or from the hobbyists. And we need a secure and modern way to expose our microservices, which are already hosted in AWS. So there are different kinds of needs. We have already some authentication services which are used with other products our customers already are aware of. So we want to reuse this. So we have a kind of a single sign-on. There's the here single sign-on service, which lets you log in as a user, and we also want to leverage this. This is an important requirement. Also, we need to have a public surface to the internet, which allows us to change things in behind without the developers out there needing to care about. So this concerns the API gateway, the API design, and also we want to modify APIs in behind or replace without changing the endpoints, the public endpoints. So the new thing is we have a large public audience, and we have the need for operational and monitoring and usage insights of this API. So these are then the requirements we came up. The API should be open and interoperable. This means existing tools should be able to connect to our APIs. Publicly available means anybody can log in and start using the API right away. Fine-grained resource access means we want to enable the customers to really change single geo features, for example, a route, a street, or a point in the cloud. All this should happen in real time. So real time in this context means when I publish a map and as a user, I change something on a geo feature, the next user seeing the map or viewing the map in his browser or mobile phone will directly see the changed object. So in the context of mapping, this could be quite complex, because when you need to prepare the tiling and all that stuff, but this should happen actually in real time. So last but not least, we needed to integrate our existing authentication system, and now I want to quickly so far about our product, and I want to show you now how we leveraged API Gateway to integrate all this, and how did API Gateway help us bringing our API to life. So one very important point to that is the protection of our backends. We needed to prevent too many requests per second, and also prevent misuse from hackers, for example, like DDoS attacks. And it's not only necessary to block, but also throttle users. So there might be a single user making very large amount of requests, and if we let all of those requests through directly to the backend, this could make a bad UX for other users. So there must be also a way, there is a way from API Gateway to make some throttling on user basis. So also the infrastructure is reliable and scalable. API Gateway is spread over multiple zones and regions, and the API tier is scaling automatically, so we don't have to care about that fact. Monitoring our API usage by each endpoint of the REST API is possible, and also we can control which user may do how much on which endpoint. So with that, we could concentrate on our efforts and on our business domain. There's no need for developing an own API gateway solution, and it's like we want to support our customers getting started quickly with maps. Also, AWS is enabling us to not have to care about the hosting of the API tier. Besides, it's offering us a coherent way for an API concept. So there is one single domain, one single endpoint to use all related services. So for the user, it's like one API, but you can have multiple microservices in behind being attached to this API gateway. So a point in the same direction is flexibility. So we can exchange whatever microservice we have in behind of the API gateway and just replace it. So one important requirement for us, as mentioned, was integrating our existing user single sign-on services Users should only need to log in once for all our offerings and services. For that, we leveraged the custom Authorizer from API Gateway. Basically, this is kind of a serverless, it's a serverless component being plugged into the API Gateway. We implemented it in AWS Lambda, and this Lambda function is getting called for each single API request coming into the API Gateway, and this function then authorizes if the user is allowed to do whatever he wants to do. So this Lambda function is calling our internal existing authorization services in behalf of the API Gateway then. So we decided to have a token-based approach. We created a microservice called Xyze Token API, and for that you only need to log in once, and you can create tokens which consist out of permissions for what you can do with our API. So once you created that token, all subsequent calls can be done with this token. All subsequent calls to all endpoints on the API, so you don't have to care about cookies or login or whatever afterwards anymore. So I can create tokens for reading maps or writing maps or changing whatever is necessary on a map. Coming back to the example with the cycling blogger, he could just create a token which is a read-only token, which just allows him to read several of his maps, and then put this, when embedding his map into a web page, he could just directly use this token in the JavaScript application without fearing that somebody could use this token to change something or manipulate something in his maps. So with that, I'd like to come to the integration of the microservices. So for many microservices, we have used the serverless approach using AWS Lambda. So what does it help us? It's providing us a standard way of onboarding a new microservice. All kinds of microservices have the same mechanism. It's the Lambda function, necessary IAM roles, and the resources necessary to attach it to an API gateway. So it's kind of a template you can have for a new module of your product. One sample is actually what I already mentioned, the token API. It's just a microservice mostly consisting out of CRUD operations for tokens. Another example is our project API, which is necessary for the Xyze Studio I shown you. So basically it's just storing the JSON blob containing the different layers of data being part of a map, which make the map. At the end, this is just, again, CRUD operations for projects. And with that, we have many more kind of components being implemented in Lambda, and I'm sure there will come much more in the future. What does it help us? So it helps us having different teams working, or small teams working on small isolated problems or services without having to interfere. The only shared resource is the API gateway then. Some components of our system were already written, and also it wasn't feasible to run them as Lambda functions. So running them on ECS, the container solution from AWS, allowed us to control scaling and also the runtime environment they're running in. All this happens in Docker then. Using the HTTP proxy integration from API Gateway just allowed us to connect it to a container using the application load balancer. So this is the way how you could integrate existing services in the same way to the API Gateway. Users won't know that actually there is a different technique how this was implemented. But once you decided to use ECS, you can still later on go on and say, okay, I want to make it a serverless Lambda component, and I switch it. and re-implement it and just change the endpoint and make it more modern then. However, this is the second type of integration we used to get our services packed together. Also, static content is needed. One sample would be a web application, like our Xyze Studios one. So it's just a bunch of HTML files, CSS, and JavaScript, which needs to be sent to the browser of a client. So also administrative UIs, like creating tokens in some user interface, is necessary. This is the token manager UI, for example. It's just a simple UI connecting the token API. Then also you can document your API right away on the same endpoint of your API. This means we are leveraging the Open API specification, which Tom already mentioned, which also plays well together with API Gateway. But you can also generate all your documentation with it and put it as static content to the same endpoint. Also, we are using the Swagger UI, which is kind of interactive documentation. I will come to that shortly. And additionally, you can put some JavaScript SDKs necessary for implementing clients for the API. So how to do that? We enabled website hosting for S3 buckets and just used the same HTTP proxy integration we used for the ECS service already. So it's just a pointer from the API gateway to an S3 bucket. By the way, all this helps you preventing cross-site scripting for the front ends, for different user interfaces, because actually those user interfaces are just running under the same domain as your API endpoint. So this is just a small screenshot of the Swagger UI. You might know it, some of you might know it. It's just showing an extract of our API endpoints, and it's kind of an interactive documentation which you can use like Postman and directly make calls against the API, trying out by putting a token into it, and that's all. So it's, like I said, it's generated out of the API Open API specification. So once your service changes, also this documentation would change and would be right away available to any customer using a new version of the API. So at the end, this is a high-level picture. There are many more components involved, but the principle is always the same. It shows the 3 integration methods, like serverless Lambda integration, integration via load balancer to ECS, and integrating static resources. This might inspire you to integrate your services with API Gateway and putting everything together on a single domain. Also, you see the Authorizer, which is being called for each single API call and calling our internal here authentication services. So you can still decide for the static content to not let API Gateway call this, because there might be resources you don't want to have authorization for at all. So how to combine all those loose parts? Having many microservices demands fully automated continuous integration and continuous deployment. At least if the number of the services is growing, it really makes sense to control all this, because very, very quickly the amount of resources being necessary to host all those microservices can go into number of more than hundreds or 200 resources necessary. But there's always some kind of scheme you need for a type of microservice. So for the Lambda functions, it's always a Lambda function, maybe some backend database, maybe some other components, but you always need to care about integrating the Lambda function with API Gateway. So this is there are very many common parts for all the microservices to attach to API Gateway. So we used AWS CloudFormation as infrastructure as code. So we are having, for each microservice, there's this CloudFormation template, which is of code, basically, and we're putting it into the same versioning control system like the software itself, like the component, the microservice. And additionally, there is some environment config. Everything together just creates a single CloudFormation stack for each component. Making a new release for a component is just an update to that stack. And that stack is can contain very many resources. Maybe it's just 5, maybe it's 15. But at the end, everything is versionable because all this is part of the versioning control system together with your code. So for us, it made perfectly sense only having one shared API gateway resource for all components. Each software component, API, microservice, or web application, brings its own resources in its own stack. This includes the REST endpoints and also the methods, so the HTTP methods description being necessary to attach it to the API gateway. So let me quickly recap what we've done to integrate our services with API gateway. We needed to use one API gateway for different kinds of integration. We used serverless components where possible, and that enabled us to scale easily in terms of infrastructure and performance, but also in operational efforts and development. So isolated teams can work on single or different microservices. Integrate static content on the same endpoint enables you to have everything at one place and prevent the necessity of cross-site scripting. Keeping control over many resources by leveraging CloudFormation, this is a very powerful tool to not lose the overview about all your resources. And then, last but not least, use API Gateway to focus on your business domain. So, to be honest, we had a half year of development for our new product, and we wouldn't have done that without API Gateway. So, API Gateway is not only a service for routing requests, it also helps you to have a centralized user tracking and throttling for the users' requests, and a central point of security control. Putting the authorization implementations into the API tier is removing the redundancy out of your components, because it's only a single point of failure in the API gateway. So normally a single point of failure is something bad, but at this point, you wouldn't have to re-implement the authorization things all over in each component, because actually it's always the same. You just need to do it once, and then there are no conflicts between different versions of how to do this. So it's basically not necessary to do it for each and every microservice, and that's helping very much for that. So just to point it out, our product is in a public beta, and it's getting lots of good feedback around the industry. And API strategy is a big piece, making it accessible and succeeding. So yeah, I hope you are getting something out of this, and yeah, I want to thank you for your attention, and we're open to questions, I think, right?
Yeah, I love that story from the Here Technologies folks. I mean, they created like a state-of-the-art API, and you can see they didn't use every feature of API Gateway that I discussed earlier, but they created a custom authorizer because they had a mature authorization mechanism they needed to integrate with. Well, API Gateway gave them that extensibility feature. They didn't necessarily use the developer portal, but they have a mature way that they have a whole engaging developers. So they used the specification for Swagger to create their documentation. You know, parts of it were serverless, so I think they started with serverless, and then where they couldn't, they used things like ECS. So they got a container technology, which frankly is a bridge to something like Fargate down the road, which Benjamin and I have been talking a little bit about. So I hope you all took something away from this session. Your attention's been fantastic. This is a great story. There's another session coming up on Thursday that we really want everybody to go take a look at, and it's around the broader serverless technologies and talking about microservices. Highly recommended. Please fill out your evaluations. We love the feedback. Just tell us a little bit about what you liked, what you didn't like. Here's our contact information if you don't want to kind of step up here and ask a question right now. They want us off stage, just kind of full disclosure, with about 2 minutes, because these things are all packed session after session after session. So we'll take questions for a minute or two, but then we'll probably migrate out into the hallway. So if anybody wants to jump up on a mic, you're welcome to. If not, thank you for your time.
Thank you.
Sure.
So in our deployment, we've kind of run into a problem of economics with API Gateway.
Sure.
Our current infrastructure is processing about 50 billion queries a day with load balancers in front of EC2 instances. And that's relatively cost effective, but when looking for a serverless transformation, what we find is that Lambda is actually pretty cost effective for handling this, but API Gateway ends up costing us an order of magnitude more than Lambda and blows out the economics. And I think that's mostly due to how feature rich it is, most of which we don't need. We just want a front for Lambda. Are there any other options on the roadmap or anything that you can talk about or recommendations to enable that kind of serverless direction for a very high volume application?
Yeah, I mean, I'm gonna ask. Let's go into the details on that on the side. I mean, I think there's a lot of different options that you could consider. I don't have anything specific in the roadmap to share with you, but let's dig into that a little bit, because I don't think we're trying to make that transition for customers a huge economic friction. I don't think that's the idea. So let's talk a little bit, if you don't mind. Like we'll go into detail on that a little bit more. Anybody else got a question?
I had one quick question for both of you. Tom, I was curious to know if AWS has any kind of team that helps clients work around a monetization strategy. And Ben, I was curious to know what the process was at here about how you decided on this token model.
So I mean, we definitely have folks that specialize in the marketplace, and those would be a logical place to start as far as your monetization strategy from an implementation perspective. Now, if it's just about how your business would benefit from different types of segmentations and stuff, I mean, we definitely can work with your account team if you're working with an account team that would love to understand your business and help you with that. I don't know of a particular team that specializes explicitly in like the economics for APIs, but there's a lot of experience that we have internally that we can draw upon. And I'll leave the other part to Ben.
Yeah, the token model actually helps us enabling developers to put credentials or a kind of credential publicly into a website. So you can bake the permissions needed to call a single endpoint or some resources into this token. It's this JWT technique. Not sure if you're aware of that. It's kind of, you can just put some content into a token, encrypt it, and then use it as basically as authorization credential. And if it would be compromised in some situation, you could just revoke it, delete it, whatever. And there is only one thing. There is no complicated way of authenticating. It's just a token which can be in a header and in the HTTP header or in the query variable. Does it answer your question?
Yeah, I was just curious to know more about it.
They are going to hook us off stage. Actually, just before I got off stage, though, I did think of a point for you. We did recently announce tiered pricing. Did you do the evaluation based on that? Okay, that might be a big one. And so I want to make sure everybody else in the room heard that as well, because that is a very recent capability that we announced. So that might be a thing to focus on. But let's go into details too. So we are going to get yanked off stage. So let's just go into that little buffer zone out there, and we'll keep taking questions as long as you guys want to ask them. Thank you.